Thanks for taking the time to join us today. Just a sort of brief introduction on my side. Prior to joining Celona, I spent much of the preceding 14 years designing, deploying, and supporting communications networks for very large events like Lollapalooza and NFL Draft. And in those environments, voice communications are especially critical because of things like crowd safety. And anyone who's ever worked on any of these shows will tell you that two-way radios are the default standard for communication in those situations. And that really arose because mobile networks don't work when 100,000 people show up to a metro park. The reason I ended up working at the music festival in 2006 was because exactly that reason, that when 80,000 people show up to a field in Leeds, the mobile networks just completely stop working. So with that said, let's quickly dive into some of the other technical aspects of voice over IP on data networks. I first started working on VoIP back in the 2000s, hosted IPPBX, and we were all often talking about the various codecs. So since the early 2000s, when enterprise started migrating to IP-based voice, we've seen quite a few developments in the codec space. In those days, in those early days, we were often operating in a bandwidth-constrained environment. Our only IP links were typically something like a T1 or an E1 lease line in Europe, which means we often had to use codecs like G729A, which you see at the bottom there next to the enterprise VoIP area. And we use that because very low bitrate codec, very low bandwidth codec. Even with overhead, just 10 to 12 kilobits per second. So recently, bandwidth constraints have eased quite dramatically, and we've seen a trend over the past sort of 8 years, 10 years even, of movement to HD voice quality. And we've really seen the biggest changes in how we use voice communication in the enterprise. Smartphones have replaced desk phones. Enterprise VoIP has moved to apps on those devices rather than dedicated devices. And this has meant supporting voice on Wi-Fi. And Andrew already pointed out some of the challenges with that, especially around roaming in the enterprise between base stations. And in recent years, and myself as a work-from-home veteran of 6 to 8 years, I would say, use of these platforms like WebEx, Zoom, BlueJeans, already increasing as we became more distributed. And in these times, we live in a world of little windows that connect us to work and family. And these platforms are trending towards using the Opus codec, which has a variable bit rate to achieve maximum voice quality. So in bandwidth terms, a private mobile network built on CBRS LTE doesn't have that many constraints from a technical standpoint. But what about, from a bandwidth standpoint, what about other network considerations like latency and jitter? Latency is just the time it takes the packet to leave the device and reach its destination. So one-way latency from your microphone to the person you're talking to speaker needs to be under 150 milliseconds. That's actually quite a big number now. It used to be somewhat of a challenge, but it's gotten easier and easier. But one issue we see coming, even though we have more bandwidth in the networks these days, one issue we often see is jitter. And jitter is the fluctuation of that latency over time. So for example, if the stream of voice packets leaving your network experiences 55 milliseconds latency for 15 seconds, and then has 4 to 5 seconds of 125 milliseconds latency, that variation is going to cause levels of jitter that will affect the quality of the call. So as I said, achieving latency of less than 150 milliseconds is easily achievable in today's networks, unless it's current generation, previous generation satellite. We're told that the next gen low Earth orbit satellite networks will be able to support voice more easily. But most voice communications now, today, whether you're in video chat or whether you're doing just a voice call, will use UDP rather than TCP over the network. And that's really because UDP is stateless, so it just sends the packets. It doesn't wait for any recognition from the other end that those packets have arrived in the right order. But if we lose one, it's not the end of the world. In TCP, if we start to experience network issues across that path, then you might start to see retransmits and all those kind of things. And that's really why most voice traffic has remained on UDP. That hasn't really changed in the last 18 years. So there are a number of ways on the network that we can mark voice traffic for priority treatment by the network. Applications like Zoom allow you to enable DSCP, aka diffserv marking for all the packets, and that can be global across your user base. So if you've got 100 people all using Zoom, you can ensure that their traffic is always handled as critical and is forwarded first. Celona private mobile networks, and Andrew gave you a little brief overview of the architecture. But the Celona private mobile network, we can configure that to recognize any DSCP marked traffic and maintain that end-to-end network QoS, including the wireless network segment. And that's pretty new. That's quite exciting. That's a new development, and that's something that CBRS will enable. So what devices can you use today? Actually, the ecosystem is pretty good and expanding every day. Push-to-talk is often utilized for critical comms between mobile workers, and Andrew highlighted a few of the verticals. My own experience in events meant using two-way radios on a very regular basis. I've been asked many times since the early days in 2006 if two-way radios could be replaced with a Wi-Fi based solution, and my answer has always been no. There was just no way I could guarantee a service that could be relied upon, especially when public safety was such paramount concern. However, with the availability of platforms like Motorola Wave and the addition of CBRS compatible handsets like the Motorola, and it's a typo there, it's an SLM 1000, that answer's changed. With CBRS, we get exceptional coverage, very predictable performance, and we can finally move that two-way radio traffic to the IP network. And there's minimal friction involved and no loss of performance. As I mentioned, the Wave system also has an iOS and Android app, so we can add push-to-talk quite easily to any of these CBRS-capable devices. Many of them are dual SIM, so when you're on your home network, wherever that may be, you'll be using CBRS, your private mobile network. And then when you move out of that coverage area, it can default back to your carrier or MNO mobile network, which is great because there's no change in how the users use push-to-talk, just the network connection changes in the back end. So for a large public event, the kind of things that I was working on, this means that all the critical comms, whether that's push-to-talk, point of sale, RFID for access control, or CCTV, all of that can be moved to a private mobile network on CBRS. And in real terms, what that means is a typical event where you're deploying hundreds of point of sale and lots of RFID scan locations that can take, crew sizes of 4 to 6 people and take multiple weeks. With a CBRS powered network, you can literally do that within hours with 2 people. So pretty big change there. And that's because we have secure frequency allocation from the FCC. We have predictable performance and enhanced security because we inherit all of the standards from LTE and the 3GPP. And that just really makes it kind of a no-brainer for certain deployments. Network managers are going to adopt this because it will mean they can deliver better service. And as a pretty big bonus, you're also freeing up your Wi-Fi spectrum for use by other applications. So we're talking about events industry specifically there, but that can just as easily be applied to a hospital or logistics center where they have lots of mixed media communication. So we've got CBRS enabled push-to-talk handsets at dedicated ones at sub $500, and a range of smartphones that suit all kinds of budgets, including, and I never thought I'd see an Apple iPhone device at the budget end of the spectrum, but the iPhone SE2 is pretty incredible considering it has the same chipsets as iPhone 11s and is available at under $400. So we've got these CBRS enabled handsets, range of smartphones, and CBRS is ready to deliver a platform that can support that PTT enabled workforce. And in ongoing discussions with customers, we see a strong trend forming where you can move critical applications, devices, and connectivity, and it will converge on a single platform. So there are obvious advantages to this, such as reducing the device count. I know there are situations where I've carried two-way radio and mobile. Those things are heavy, not the mobile, the two-way radio. But so reducing device count is always good from the user point of view, and from the management point of view, you've got less devices to deal with. Beyond that, the superior coverage, predictable performance of CBRS will provide users with an outstanding experience, and that relieves pressure on help desk function. Just means everyone is much happier. With all that in mind, there's one device which we think will drive a lot of this convergence due to some of the features that it has. The Xcover Pro, fully ruggedized to a military spec, Android 10, and is designed specifically for enterprise use. There are a number of enhancements on there which make it especially appealing, one of which is the programmable side button, which is great for push to talk, because that's how we use two-way radios. There's a side button to talk. And of special interest to those of us who use Office 365, Microsoft recently announced that Teams will soon add support for push to talk as well, which that's pretty cool. That's being driven from, we've got devices coming through, plus applications being developed to specifically take advantage of these devices and their developments. Our VP of Marketing, Oza, has got the Xcover Pro on test right now. And during that time, of testing, we've learned that you can assign specific apps to always use the CBRS network. Now, that could be very helpful both in terms of security, but also in terms of keeping those critical communications inside your own network. And lower priority traffic, so web browsing, let's say it's got some social apps on there as well, that can all simultaneously be transacted on Wi-Fi or on carrier networks at the same time your critical apps are using the CBRS network. So to summarize then, a CBRS-based private mobile network will deliver the predictable performance required for voice comms, and we have already a great ecosystem of devices that suit a range of budgets and use cases. So no matter your environment, there are definite benefits in adding CBRS to your wireless networks.